Let me introduce to you the rarest motherboard on the internet, the Integraph P6450A. It is a motherboard that supports the 386 and 486 CPU. Very little is known about this board as no documentation, datasheets or manuals exist online. The board was used to be part of an electronics museum back in 2010 at Coventry University. In 2012 a new engineering building was built and the electronics department had to put the museum exhibits into storage as they had to move to the new building and had no space for the museum. In 2019 the Beatrice Schilling building was opened and new spaces for the electronics department were made available. We then decided to rebuild the museum. But let's go back to the board itself. Besides the main CPU socket, the board allows a Go processor to be added to the system for mathematical operations. When the system is running, both CPUs would work together and from the user's point of view would look as if it is a single processor. This was common method of adding the ability of calculating floating point numbers. The 486 CPUs could only work with 32-bit values and having the coprocessor, typically a 487 CPU, allowed any computer system to perform much more useful operations. The 486 CPU is installed onto what was known as PGA socket, which can have 196 pins for PQFP packaged CPUs or 208 pins for REST-QFP. The coprocessor can be installed in the socket just below the main CPU. Both the 486 and 487 CPUs were the most popular chips in the early 90s, before the Pentium era. The P6450A board supports up to 2 hard disk drives with limited size and up to 2 3.5-inch floppy drives. The board also has a dedicated PS1 keyboard controller located in the upper right corner. Right next to it, the real-time clock, or RTC, chip is located. On this motherboard, the infamous DS1287 RTC chip was used, which has a built-in battery to store the BIOS settings while power is off, similar to coin batteries on motherboards. On the right side of the CPU sockets we can see 9 memory chips which are used divided for CPU cache memory and what is known as shadow memory, which is essentially a duplication of the routines inherent in the basic input/output operating system or BIOS of the computer system. Right next to the IDE interface header, the chipset IC is located here, and the BIOS is stored and programmed onto an EEPROM ceramic chip here. The BIOS flashed on the chip was quite old, and because of this a few limitations on the peripheral devices are imposed. One major limitation is that the BIOS will not be able to detect and boot from a hard disk that is bigger than 10 GB. On the top middle side of the board we have 8 SRAM sticks which total to about 1280 KB. Right below it we have the socket for peripheral boards. This socket is called an Industry Standard Architecture Slot, or ISA, and it is the predecessor of the PCI slots, still used in modern computer systems. Finally, we have the video controller chip that outputs video in VGA standard. The connector here is where the power supply for the board is connected, and the header next to it is for connecting a standard joystick controller of the era. All of the input and output ports on the board are located on the left edge, and these consist of the PS1 connector for the keyboard, 2 serial communication slots, 1 parallel slot for printers or a MIDI peripheral, the video output port which is a VGA standard, and a PS2 connector for a mouse. There are also several header pins on the other edges of the board, but due to lack of documentation they are currently a mystery. The board was mounted on a clear plastic surface. All needed external peripherals were also mounted around the board so that it could be displayed while working in the previous museum. When I put it all together and turned the power on, the system attempted to boot up. After checking the memory, the first problem became evident. The battery within the RTC chip, the DS1287, was depleted. This meant that the BIOS would not be able to store the system configurations when powered off. After doing a brief search online, I discovered that people have wanted replacements for the DS1287 so much, that a replacement chip was being manufactured in 2021 and it is available. I did purchase the replacement, and while waiting for the delivery I decided to remove the original chip and install a socket so that future change would be easier.
To nie ma takiej